Hello, people. Today I'm excited to take you behind the scenes of how I created my game submission for the Flame Jam 2025 Space Tracer. The jam challenged us to build a game using the awesome Flame engine, which, as many of you know, is built on top of Flutter. The theme, the space race. On top of that, we had to pick a diversifier, and I went with shaders. My vision, a full-on 3D racing experience set in space. Some of you might remember a full 3D demo I did with Flame using stacked planes. Well, this time I wanted to go all in and create a true 3D experience. So where did I start? By tackling the fundamentals. Rendering a basic 3D triangle and setting up a 3D camera. This camera needed to know its 3D position, its 3D rotation, and crucially, how to generate that all-important projection view matrix. Once I had that foundational piece working, it was time to bring in the star of the show, the spaceship. I hopped into Blender, modeled it, and prepped it for export as an OBJ file, a simple text-based format that's easy to work with. Now here's a little technical hurdle I encountered. Flutter's draw vertices function only deals with 2D coordinates, so my 3D triangles needed to be flattened. I also saved the inverse of that flattening matrix so I could bring it back to 3D later when combining it with that model matrix. After a bit of trial and error, as these things often go, I finally cracked it. It's alright. Let's jump into day 2. With the basic 3D rendering in place, it was time to add some visual flair. Textures. Now, as soon as the textures popped, a classic 3D rendering challenge reared its head. Depth. In most 3D engines, depth buffers handles this, making sure closer objects obscure those further away. But Flutter's canvas doesn't have a built-in depth buffer. My solution, the trusty painter's algorithm. This meant sorting all the triangles based on their depth and then drawing them from the furthest to the nearest. To optimize this a bit, I also implemented a big face culling. If a triangle wasn't facing the camera, no need to draw it. Next up, the asteroid. This process was surprisingly straightforward. This was also a good point to do some performance testing. How many of these space rocks could I realistically have on screen? The answer? Not as many as I initially hoped. Time for more optimization, focusing on pre-calculating as much as possible. Then, I made the spaceship follow the camera's movement. Interestingly, I learned that updating the spaceship's position in its own update method caused jittering. Moving that update logic into the same method as the camera's movement smoothed things out beautifully. More optimization came in the form of level of detail, or LOD. This means objects further away would be rendered with fewer triangles, so boosting performance. I also added another culling technique. If a triangle was completely behind the camera, I simply skipped rendering it. Then it was time to tackle the skybox. I crafted an environment in Blender, complete with a planet using a procedural shader, and then rendered it as a panorama. The challenge here was figuring out the relationship between the camera's field of view and the actual rendered field of view. Thankfully, that part was pretty direct. However, getting the skybox to move correctly in sync with the camera, that was trickier than I anticipated. Looking back, I think jumping straight into code without some initial calculations on paper made it harder. But hey, in the end, it worked out. While I was in the skybox mindset, I also implemented a light probe to add some lighting to the scene. Alright, in today's 3, previously I was using Euler angles to handle the rotation of the camera and the spaceship. But then I realized that for a spaceship that can rotate freely in 3D space, Euler angles can lead to something called gimbal lock. Not ideal. So I started looking into quaternions. Now, quaternions can be a bit mind-bending, so I opted for rotation matrices instead. While they have more parameters than quaternions, the concept is so much easier to grasp. Each column simply represents the direction of the forward, right, and up axes. With the rotation matrix in place, I revamped how the spaceship followed the camera, making it a much smoother and more natural movement. Next on the list, checkpoint rings. I went with a rectangular shape to keep the triangle count low. Every bit of optimization helps. Just like before, these were modeled, unwrapped, and textured in Blender. To make them stand out, especially the glowing bits on the sides, I added an emission texture and shader. If the emission texture is white, Those parts shouldn't be affected by the scene's lighting. Then came the task of level design. Blender's curve tool made it surprisingly easy. I could draw the path I wanted and then distribute a simple proxy mesh, which is just an edge indicating there is orientation along that curve to mark where each ring should go. Oh, and I also created a lower detailed version of the ring for when it's further away. Once the level layout was done, I jumped into Krita to create the lens flare effect. The rendering logic first checks if the camera is facing the sun. If it is, it projects the sun's direction onto the screen. For the secondary lens flare, its position is mirrored across the center of the screen, 0, 0. So if the projected sun was at, say, 34 and 98, the secondary flare would appear at minus 34 and minus 98. I also made the secondary flare rotates to face the primary one. Finally, for day 3, I started working on the main menu. I rendered a shot from the skybox scene I had already created, then brought it into Krita for editing. I added the game's title, some tags, and a touch of lens flare. The process for this was pretty standard for anyone who's worked with Flame. I just utilized its overlay feature. Alright, let's dive into day 4. I kicked off this day by doing some much needed code refactoring. Time to edit things up. After making the code cleaner, I decided to push the optimization of the low detail ring even further, reducing its triangle count from 16 all the way down to just 4. With potentially tons of rings in the scene, I had an idea. What if I only kept one instance of the ring's 3D mesh in a cache? Then, every ring object in the game world would just store its unique rotation and positions, and for the mesh, it will just simply referencing the single mesh in the cache. This would save a lot of memory. Next, I started dabbling a bit with the select level menu and began building a child object system. This was initially for the ship's jet effect, but while working on this, I realized that my previous implementation for making the spaceship smoothly follow the camera wasn't quite right. Instead of getting bogged down, I moved on to something I felt was more pressing, continuing work on the select level menu and then adding the in-game timer and countdown. After some adjustments to the ring placements in the level, I also added the lab entering counters to the screen. Following that, I implemented a basic pause menu and a simple finish menu. Then came a bit of polish. I made it so the spaceship smoothly decelerates when the series is finished, and I added a subtle vignette effect to the screen. Next on the agenda, the jet. I modeled jet in Blender, then incorporated its texture into the main spaceship texture. After that, I wrote a class to handle its behavior. Initially, I had normal calling enabled for the jet, but turning it off actually gave a much better visual result. I also programmed the jet size to dynamically scale based on the spaceship's speed. Working on the jet reminded me of the spaceship movement issue I had spotted earlier, so I took some time to finally fix that. And success! Everything was now moving as it should. Moving on, I tidied up the screen interface to make it cleaner, and then I started working on the minimap. My approach here was to simply take a screenshot of the track from Blender, edit it in Krita, and then export it as an image. Getting the minimap to align perfectly with the spaceship's position proved to be a bit tricky. Looking back, since I already had the positions of all the rings along the track, I probably should have just used those to render the minimap in-game. That would have been much simpler. The last thing I tackled on day 4 was changing the checkpoint hit test from a discrete check to a continuous one. I had noticed that sometimes the game wouldn't register that the spaceship had passed through a checkpoint, and this change aimed to fix that. Alright, let's see what day 5 brought. On this day, my focus shifted to creating more level. Starting with the second level, this involved crafting the skybox texture in Blender, followed by setting up the LED Pro, then I repeated the exact same process for the third level. With the environments for the new levels in place, I moved on to the level design itself for level 2, and then created its corresponding minimap. You guessed it, the same steps followed for level 3. Once all the levels were structurally complete, I went back to select level menu and some polishing. I add some visual icons and the record field. I also give the finish menu a little visual upgrade and smoothed out the camera movement in the game. Next up was the how to play menu, followed by implementing a cool increasing field of view effect when the player hits the boost and adding the option to invert the controls in the settings menu. Then it was time to populate the new levels with asteroids. Initially they were grey like the moon, but then I realized they look a bit too similar to the checkpoint rings, which could be confusing for the player, so I changed their color to a more distinct brown. The final task for day 5 was adding collectibles, crystals. I modeled this in Blender, the shit made of two tetrahedrons joined together, textured them, and then, just like with the rings and asteroids, I mapped their positions onto the levels. To give the player feedback, I added a score interface to the game UI, displayed the score on the finish menu, and also showed the high score on the select level menu. Finally, I coded the logic to detect when the spaceship collided with a crystal. Now let's jump into day 6. I started by putting some polish on the how to play menu and then went ahead and added the crystals to the second and third levels. After that, it was finally time to tackle the music. I began by creating the main melody line. There are a few ways to approach this. First, you can just directly place notes and see if it sounds good, or you can hum it first. I like to combine both methods and see what works best. My approach to music is pretty similar to my coding, a bit of experimentation. Since my piano skills are, shall we say, very basic, and I don't have a MIDI keyboard, I just record the rhythm, and then move the notes around in LMMS according to what I hunt. If you're doing this, you need to lay down the drum track first to establish the tempo. Next up, chords that fit the melody line. For this track, I made the chords play a rhythm too. Then I moved on to creating the melody lines for the pre-chorus and chorus sections. And of course, I made the drums sound a bit fuller. I often use drums to help create transitions between different parts of the music. One really important aspect of music production is layering instruments and paying attention to dynamics. Dynamics simply means that the music shouldn't be loud all the time. Variations in volume add a lot of interest. But yeah, once all that was done, I exported the track as an OGG file and then integrated it into the game. For the sound effects, things like collecting crystals, button clicks, and the countdown, I also created these in LMMS. For the boost sound, I just made a simple noise in Audacity. However, in the end, I decided not to use the sound effect because it unfortunately caused noticeable frame drops every time it blooped. Moving on, I started working on the music for when the game is finished. It was a pretty similar process to creating the main level music. The last thing I did on day 6 were some more code refactoring and polishing the user interface. Alright, let's talk about day 7. I didn't do a lot on this day, it was mostly some more refactoring to keep things clean, and I also created the music specifically for the second level. Let's see what happened on day 8. I made a small but helpful change. I updated the shape of the spaceship on the minimap to make it clearer. I also finished up the music for the second level. Then it was back to the code for some more refactoring. After that, I decided to experiment with adding a bloom post-processing effect. To be honest, I really loved how it looked visually. It added a nice glow to things. However, this effect turned out to be quite performance intensive, and since I wasn't sure how to optimize it further at that point, I made the tough decision to discard it in favor of smoother gameplay. At the end of day 8, I started laying the groundwork for the third level's music. This time, my approach was a little different. I felt like my creative well had been a bit drained after making the first two music tracks in quick succession, so I decided to start with the chord progression first. I thought maybe this would help spark some new melodic ideas. Alright, let's talk about day 9. On this day, I focused on writing the melody for the third level. Thankfully, the chord first approach seemed to work, and I was able to come up with something I liked, especially since I was feeling a bit creatively fatigued after the previous music efforts. After that, it was back to the code for some more refactoring. I also managed to catch and fix a few sneaky bugs. Once I felt like everything was in a reasonably good state, I went ahead and uploaded the game to itch.io. However, at this point, it was still set to private. And that brings us to day 10. This was all about final touches. I did some more refactoring to really polish everything up. And yeah, that's it. That's the journey of how I created Space Tracer for the Slim Jam 2025. Thank you so much for watching.